Alright everyone, I'm Shaurya and today I will be giving you the solution video of the fourth problem from the TCP open contest. I hope you enjoyed the contest as well as all the problems. So let's deep right into it. So the problem is maximum trash collection, right? The problem is maximum trash collection. Drunkenstein is in a 3D space filled with trash cans. The space is of size L cross breadth cross height, okay? Length cross breadth cross height. Each unit cube contains a trash value. It can be positive, negative, or zero. He can choose two adjacent cubes and flip their signs, positive to negative and negative to positive. He can do this any number of times. Okay. Find the maximum total trash he can collect after performing the operations. Okay. Now it is explaining what does the adjacent cube means. The input format is simple. We are given length into breadth into height. We are given three integers. Three integer that shows the length is given, the breadth is given, and the height is given. And then after that, the L into B into H integers follows. Okay, so total number of integers that will follow will be length into breadth into height. Represents the trash value in space given in layer wise manner. Okay, the first breadth into height number represents the first layer, that is x equals to 0. The next B cross H number represents the second layer, that is x equals to 1. Okay, the constraints on length into length, breadth, and height is 100, and the value in a cube can be at most 100 and at least minus 100. Okay, in output we have to print a single integer that represents the maximum trash he can collect. All right, so the problem seems very difficult, right? So what the problem is saying, we are given a 3D space, let's say, like, you know, like a 3D cube space, and then in this matrix, in this 3D grid, we are given values, and what we can do, we can choose two adjacent cube cells, right? So like, let me show you what the problem is saying. Just a second. Okay, this is one, and then this is one, right? And then this. I hope you guys are able to visualize it. Okay, so these are the two grids possible, right? So I don't know you guys are able to visualize it or not, but imagine a Rubik's cube, right? In a Rubik's cube, all the cubes are nothing but cells, and in those cells there are values. The values could be 0, negative, or positive. Now what it is saying, we can take the adjacent cubes, right? The cubes that share a side. See, in this, they share a common face, either left, right, front, back, above, or below. Okay. So in those adjacent cubes, what we can do, we can flip their signs. We can flip the both of those signs. Okay. Let's see the sample input. The sample input is length is given 2, breadth is given 2, height is given 2. So we are given two grids like this, placed one upon each other. In the first grid, the values are 1, minus 2, 3, and 4. And assume it is placed above this. The value is 5, minus 6, minus 7, minus 8. And the output is 36. Now let's see how the output is 36. You can read the solution given. Okay, just a second. You can read the solution given, or sorry, the explanation given from the site itself. I'm explaining how it came out to be 36. So what we can do, we can select these two numbers, minus 7, minus 8, minus 7 and minus 8, and flip their sign. Then it will become 7 and it will become 8, right? And then what we can do, because these were adjacent, these were sharing the same row, we can also flip these two signs, but there will be no profit of flipping it, right? It will become positive, but it will become negative. Now what we can do, since this layer is just below this layer, so this cell and this cell will also be adjacent, right? So we can flip the sign of this 2. So it will become 2 and it will become 6. So after that, how the layers will look, this layer will look like 1, 2, 3, 4, and the layer above it will look like 5, 6, 7, 8. The sum of all is nothing but 1 plus 1 to 8. The sum from n natural numbers, that is nothing but n into n plus 1 divided by 2, that is 8 into 9 divided by 2, that is 9 into 4, that is nothing but 36, right? Yeah, 36. Okay. Similarly, in the second test case, we are given 3 grids like this. Yeah, so the grids are like this. Okay, it is not copying, I don't know why, but yeah, we are given 3 grids like this and the values are also given and we have to perform the same operation. So I hope you understand ki how do we need to proceed. Okay, so if you will go into like the thinking of the process and simulating it, ki okay, let's simulate, let's count the adjacent, then it will be very hard to implement. It will be really very hard to implement. Why? Because first you are given a 3D matrix, right? So I don't know you guys have ever dealt with a 3D vector or not, but it is very hard, right? So the solution is very simple. It is based upon a simple approach you might have learned, that is bubble sort. In bubble sort, what generally happens that let's say here we have 4, then we have 1, 2, 3, 5, 7, right? So in bubble sort, what we can do, we can just swap the adjacent elements, right? So what we do, we swap this one, so it becomes 1, 4, 2, 3, 5, 7. Then on the next step we swap this one, so it becomes 1, 2, 4, 3, 5, 7. And in the next step we again swap this one, so it becomes 1, 2, 3, 4, 5, 7, and hence it becomes sorted, right? So what we did, we basically swapped the adjacent elements and we moved this 4 from this position to this position, right? Similarly, let's say if it was like this, -4, 1, 2, -3, 5, 7. Now what I'm doing, I'm not able to swap, but I'm able to like the adjacent elements, I can change their signs. So in first step I will change the signs of this 2, it becomes 4, -1, 2, -3, 5, 7. Then in next step I change sign of this 2, it becomes 4, 1, -2, -3, 5, 7. And in the final step I will change sign of this 2, so it becomes 4, 1, 2, 3, 5, 7. So can you see, like I removed the negative signs, this one and this one, right? So that is the main observation in this problem, that we can perform we can move the minus sign around everywhere, even in the grid. Like in the simple array I showed you how we can move the minus sign from here to, let's say, here, right? In a 2D grid we can do the same. In a 2D grid we can do the same. Let's say here we have -4, here we have let's say 4, here we have -3. So first we will move it here, then here, and then finally this 2. And if we want to move it, let's say here, then here, here, and then this 2. So in a 2D grid also we can move the negative sign from here to here. Similarly, in a 3D grid also we can do it. So basically why I constructed this problem was, I have solved one question on Code Forces that was around 800 rated, that was this one. Then I solved another question on code forces that had the same idea but in a 2D grid. That was around 1100 or 1200 rated, I guess. That was this one. So I thought, let's create an advanced version around 1300 to 1400. That is nothing but again the same logic but in a 3D grid, right? So these two questions you can find in Priyansh Agrawal's CP31 sheet. And this problem, if you have solved both of those problems, you'll be able to figure out what we have to do in this problem. So now what we have to do, we have to count the all the negative numbers. So the solution is simple now. We have to count the negative numbers. Okay. If we count the negative numbers present in the whole 3D grid, what we can do, we can take two negative numbers. We can take this negative number and this negative number and annihilate it. It is pairwise annihilation, right? So if we have, let's say, four negative numbers, then we can annihilate this one and this one. So we will remain with zero negative numbers. But if say we have five negative numbers, then we can pairwise annihilate numbers and then one negative number, or I should say one negative sign, will remain. So it depends on the parity. It depends on the parity. So let's jump into the problem solution, then you will understand it more clearly. Okay. So what I did here, I took length into breadth into height. I took length, breadth, height as input here. And then there's one very clever thing I did. I did not take a vector of vector of vector, right? I would have taken a vector of vector of vector. But I know I just need to count the negative numbers. So we can do it in a simple vector as well, right? So I took my n as length into breadth into height. Okay. So n here is nothing but 2 into 2 into 2, that is 8. Then I created a vector of size 8 and took the input, the whole input, as a linear vector. All right. Then I have printed the vector here, v. You can see my vector here is this one. 1, minus 2, 3, 4, 5, minus 6, minus 7, minus 8. Right. Then I have initialized a counter, count negative, and a total sum as sum. Then what I did, I traversed the whole vector. If x was negative, I made it positive by multiplying it by minus 1, multiplying it by minus 1. I made it positive and I incremented my negative count, right? So I incremented my negative count. And at the end, what I'm doing, I'm taking the total sum as well. Okay. So after I have done all this, you can see I'm again debugging my vector. So after the changes, the vector looks like this. So it contains all the positive values, right? It does not contain any negative value. So now I'm counting my negative. So here you can see the count negative was 4. Okay. And my sum is nothing but 36. That is sum of sum of first 8 natural numbers. Now what I'm doing, I'm taking the minimum of all the elements. Minimum of this will be nothing but 1, right? Minimum of this positive vector, the vector that has all the elements as positive, will be nothing but 1. And then what I'm doing, if my count negative was odd, then one negative sign will remain. Suppose if the vector was 1, 2, 3, 4, 5, 6. Okay. Here I have minus 1, minus 2, minus 5, minus 6. Okay. So here my vector had 3 negative numbers. I can pairwise annihilate these two. So it will remain 1, 2, 3, 4, 5 and 6. Now, as I told you before, we can move the negative sign anywhere. So where do you think the negative sign should go? To the minimum element, right? To maximize the overall sum of the array. So we will move this negative sign from here to here. So it will become minus 1, 2, 3, 4, 5, 6. And this time the total sum will be 2 plus 3 plus 4 plus 5 plus 6. That is 5 plus 9 plus 14 plus 6 is 20. So it is coming out to be 20. Yeah. Okay. So in this one, we can calculate it one more way. Like, see, here the total sum first of financial numbers is nothing but 6 into 7 by 2, that is 21, right? Minus, sorry, here we have to minus 1 also, right? Because we have to consider this minus 1 as well. So overall answer will be 19 in this case. Yeah, so total sum is 21, and after that we have counted this one twice, right? We have counted this one twice. Once we are considering it's positive, so we have considered it. In the second time we have to remove it. So here you can see what I did. I took the minimum element to give it the negative sign. If the count was odd, then I am subtracting the minimum element 2 times from the overall sum. If the count was even, so we can always pairwise annihilate all the negative values, and hence the vector will remain only positive. So the sum will be the total sum of the vector. So for sum, you can also do one thing. For sum, after this step, you can use a accumulate function, right, to get the overall sum. So in the next problem, you can see here, in the next test case, here the vector was this. After changing, the vector became positive. The negative numbers were 9. There were 9 negative numbers. You can see 1, 2, 3, 4, 5, 6, 7, 8, 9. Now if you will see it as it is, you will think like how we will move it. Like minus 2 is here, 2 is here, we cannot move it anywhere, right? But we can move minus 2 and 2. The sign will come here, the sign will come over here, and from here we can annihilate this one. Move 4 to here and then annihilate this 2, right? So in this way we can annihilate the negativity. So again, here the count negative was coming out to be 9, that is odd. So in this case we will enter this loop. The total sum was 59 and the minimum element was 1. So the answer will be 59 minus 2 times the minimum element, that is 57. Okay, so this was a purely greedy solution. This was a purely greedy approach, greedy way. The problem was based on bubble sort. Let's discuss the time complexity of it once. The time complexity is, as you can see, very simple. We are taking just a big O of n time complexity, taking the input and using a loop over here. So the time complexity is simple. Time complexity is big O of n, and space complexity is also big O of n, right? This problem was also appeared in USSCO silver round. You can check it. There they have a, I don't remember, there they have a greedy playlist of silver. You can check out there as well. So okay, if you guys understood, thank you. And if you have any doubts, you can comment it in the comment section. Thank you.